If the center of the Earth is burning at over 5,000 degrees, why is the bottom of the ocean so cold it could freeze your blood in seconds? Pause for a second. Think about that. Something doesn't add up. And before you say, oh, it's just science, I need you to stay with me, because what I'm about to show you will make you start noticing something you've probably ignored your whole life. And honestly, it changes everything completely. Most people don't even question what we were told. The Earth is a giant ball. In the middle of that ball, there's a core. That core burns somewhere between 4,000 and 6,000 degrees Celsius. That's hotter than the surface of the sun. Wild, right? Now picture this. You've got boiling hot rocks sitting right underneath the ocean floor, and the ocean floor is right there, sitting on top of it, touching it. Scientists call this the oceanic crust. It's only about 5 to 10 kilometers thick in most places, thinner than some mountains are tall. So if you have fire on one side and water on the other, separated by a thin layer of rock, why is the deep ocean sitting at around 2 degrees Celsius? 2 degrees. That's almost ice. And we're talking about the Pacific Ocean, the Atlantic, the deepest trenches on this planet. Places like the Mariana Trench, nearly 11 kilometers straight down. Cold, dark, frozen. Not warm, not heated, not even slightly toasty. Does that not bother you even a little bit? Here's where it gets really uncomfortable. Think about your kitchen. If you put a pot of water on a stove, even on low heat, that water warms up every single time. No exceptions. Heat rises, heat transfers. That's basic physics they taught you in 5th grade. So why doesn't that same rule apply to the ocean? You've got a core hotter than the sun underneath it, and the water above stays near frozen. They'll tell you the pressure does it, that the depth creates cold. But wait, pressure doesn't create cold. Pressure creates heat. Compress anything fast enough, and it gets hot. That's how diesel engines work. That's how stars are born. So now pressure cools water. Since when? Then they say it's because sunlight can't reach the deep ocean, so it stays cold. Okay, but the heat isn't coming from above. We're talking about heat supposedly coming from below. Why would sunlight have anything to do with it? And here's the part nobody wants to talk about. The same science textbooks that tell you the core is thousands of degrees hot are the same books telling you the ocean is cold because sunlight doesn't reach it. Both things can't be the dominant explanation at the same time. So which one is it? Because right now the story has more holes than the science they're trying to protect. And here's the part that should make you stop scrolling and really lock in, because what I'm about to say changes the entire frame of this conversation. What if the reason the deep ocean is cold is because what's beneath it isn't what they told you it was? What if the heat source is positioned differently than a spinning ball of fire in the middle of everything? What if the map is wrong? On a flat Earth model, the heat doesn't come from beneath you in a central core. The warmth comes from above. The sun moves in a circular path over a flat plane. The edges, the outer rim, stay cold. That's where your ice is. That's where your deep, frozen ocean water comes from. Cold water sinks. It collects at the deepest points. The further from the central heat source, the colder everything gets. And honestly, that fits perfectly. Think about Antarctica for a second. It's always described as the coldest place on Earth. On a globe, it's just the bottom. No special reason for it to be colder than the Arctic, other than axial tilt. But on a flat plane, Antarctica is the outer edge, the wall, the furthest point from the central warmth. Of course, it's the coldest. Of course, the deep water that circulates from there stays cold. Deep ocean currents literally flow from polar regions into the deep trenches. Cold water from the outer edges, pushing inward and downward, filling the ocean floor with the coldest water on the planet. The model actually makes sense. And here's the wild part. Even globe Earth scientists confirm that deep ocean water originates from polar regions. They call it thermohaline circulation. Cold, dense water from the poles, sinking and spreading across the ocean floor. They just never connect the dots on what that actually implies about where the cold is really coming from. Every video on this page starts with one simple question, the kind you were never encouraged to ask, and follows the logic wherever it actually leads. No complicated language, no lectures, just the kind of thinking that makes you stop and say, why did nobody ever put it to me like that before? If this one cracked something open, even slightly, stay with us. Follow the page and watch what comes next, because the questions keep getting bigger, and honestly, you won't want to miss where they lead.